Hello, let's look at the topic today. It's inverse functions. Before we talk about the inverse functions, let's review what it is and the one-to-one function. One-to-one function means one x corresponds one y. Vice versa, one y only corresponds one x. Vertical line and horizontal line tests. So we know this is the vertical line. From this green line, we can see for this function, 1x has one y value. If I draw the horizontal line, I will find I have 1y. This 1y corresponds to x values. So we can know this one is not a one-to-one function. And let's look at this one. From the vertical line test, we can know this one has 1x corresponds 1y. From the horizontal line test, we can see 1y only corresponds 1x. So this one is the one-to-one function, but this one is not. Okay, let's look at the inverse function. We will look at the first example. Given original function y equals f of x equals 2x plus 3, let's find its inverse. The steps of finding an inverse function are as the following. So step 1, we interchange x and y. So that means I change this y to x and change this x to y. So it will be 2y plus 3. Step 2, solve for y. This is mainly because all the functions should be written in the form of y equals f of x. So we still want to use x to represent this y. So what we will do when we look for this y is, we take this y as a kind of unknown variable, but we just pretend that we know this x value. So what I will do is I move 3 to the other side. It becomes x minus 3 equals 2y. Then I divide both sides by 2. So I will get y is x minus 3 over 2. So this function is the inverse function. The notation for the inverse function is f inverse brackets x. So this notation is called f inverse of x. And you guys need to know this -1 is not the exponent -1. So if you look at the conclusion here, you will see f inverse of x, this symbol is not 1 over f of x. And this symbol is just an inverse symbol. So this is the reason we put a -1 between f and the x. Okay, right now, our second task is to graph both functions on the same grid. So what I will do is, we will see both of these two functions are linear functions. So we will use two different methods to graph these two linear functions. But anyway, we know both of these two linear functions should have the straight line as the graphs. So let's look at how can we graph the first line. So for the first line, I will use y-intercept, which is 3. Or we can see this is a point 0, 3. And this one shows me the slope is 2. Slope equals rise over run. So I can change this number 2 to positive 2 over positive 1, or negative 2 over negative 1. Based on the rise over run, from this point I can go up to right 1, up to right 1, up to right 1, or I can, starting from this point, I can down to left 1, down to left 1, down to left 1. I do believe right now we have plenty points to form a line. So I connect those points up. Okay. When I connect all those points up, I also want to find some very important points on the line as well. One point is y-intercept point, and the other point is this one. This is the x-intercept point. I let y be 0 and find the x value. This x value is negative 3 over 2, 0. Let's pick up one more point. For example, this point. We can write out the coordinates for this point is 1, 5. Okay, so right now, I want to use the red color to graph the inverse function. It's a linear. So the graph of this linear is still a line. But this time I will use a different method to graph this line. I will look for the x-intercept and y-intercept. So y-intercept is easier. I just say x equals 0. If x is 0, I plug in the y-intercept is negative 3 over 2. So that means the inverse function pass through this 0, negative 3 over 2. And the x-intercept point is, I let y be 0. So this point is x equals 3. So 3, 0 is the x-intercept point of the inverse line. So right now, I think we have 2 points already. I can join these 2 points up and form a line. I will change this inverse graph to a red color. Okay, so this is the original function graph. This is the inverse function graph. Then we find, okay, if we look at these 2 lines carefully, I find these 2 graphs are reflected over one line, and this line is the diagonal of the coordinate system in the first quadrant and the third quadrant. The equation of this line is y equals x. So for 2 functions which are inverse to each other, they must be reflected over y equals x line. Okay, why? Because I change x to y and y to x. And if you look at all those points, compare the points, you will find the original function pass through negative 3 over 2, 0. The inverse function pass through 0, negative 3 over 2. The original function pass through 0, 3, this point. The inverse function pass through 3, 0. So I can see this inverse function must also pass through point. I switch 1 and 5 around. So this point must be 5, 1. So what's the meaning of inverse function right now in mathematics? Inverse means I switch x and y around in the original function. So based on this function, inverse function notation, let's find f of f inverse x. So if you still remember, okay, the composite function concept, you know this one is f of f inverse x, which means I plug the inverse function into the original function. My original function is 2x plus 3. This time, this x should be replaced by the inverse function, which is x minus 3 over 2. If we simplify this one, I will see I cancel these two 2's, and I only have x minus 3 plus 3. Minus 3 plus 3, I still can cancel these two numbers. So you will find f of f inverse x is x. Let's look at what is f inverse of f of x. This one means f inverse of f of x. That means I plug the original function into the inverse function. Okay, so my inverse function is x minus 3 over 2. So this x should be replaced with the original function, which is 2x plus 3. Plus 3 minus 3, they cancel out. 2x over 2, it's also x. So this is a very interesting conclusion for the original function and its inverse. And we find this original function just looks like f to the power of 1 times f to the power of negative 1. Using the exponent law, so we add the exponents up, they cancel out. So you only have x left. Okay. So here are the conclusions that we can draw from this example. If y equals f of x has an inverse function, this new function is denoted f inverse of x. And you guys know this inverse is not the same as the exponent negative 1. So this one is not equal to the reciprocal. The inverse must be a function as well, and so it must satisfy the vertical line test. We will talk about this point in example 2 again. The inverse function is the refraction of the original function in the line y equals x. Original function and its inverse function satisfy f of f inverse of x is x. F inverse of f of x is also x itself. Right now, let's look at the second example. Given the original function y equals x squared, does this function have an inverse? If we go back to the conclusion points here, you guys need to remember the inverse must be a function as well, and it must satisfy the vertical line test. So an inverse function should also pass through the vertical line test. Let's look at this original function first. Let's graph this original function very quickly. It's a parabola. Okay. So this point is 0, 0. This point is 1, 1. This point I used is 2, 4. Here, this point I used is negative 1, 1. This point I used is negative 2, 4. Okay, why did I illustrate all those coordinates? It's simply because right now I want to graph its inverse, instead of looking for the expression of the inverse. Okay, so I want to graph it. So if I want to find its graph of the inverse, what I will do is I graph the reflection line first. Okay, from example 1, we know two functions which are inverse to each other should be refracted over y equals x line. Okay, then how can I draw the reflection image? If you have trouble, it's okay. I'm not drawing the reflection image right away. I will use the points to help me. And from the example 1, we know the inverse function can be obtained by interchanging x and y in the original function. That means for the coordinates on the original function, I just switch x coordinate and the y coordinate. So 0, 0, I switch them around. It's still 0, 0. 1, 1, if I switch around, it's still 1, 1. 2, 4, I switch around, becomes 4, 2. Negative 1, 1, I switch the x coordinate and the y coordinate, it becomes 1, negative 1. Switch around these two coordinates, it becomes 4, negative 2. So even if you have trouble graphing the reflection image, with all those points, you will see the reflection image very easily this time. So we will see blue is the graph of the inverse of the original function. But we will look at the blue graph right now. If we draw a vertical line, you will see 1x corresponds to y's, which means this blue graph does not pass through the vertical line test. So that means this blue graph is even not the graph of a function. That means this original function has no inverse function on its domain or real numbers.